Welcome back. Today we're going to talk about more transformations on quadratic functions when we graph them. So what we're going to be looking at today is a quadratic equation of this form. G of x is equal to some number, we usually call that a, right? The leading coefficient is called a, times x squared. Now the first case we're going to look at is when this number out here is -1. So what that looks like is g of x is equal to negative x squared. And bear in mind that we're using g of x because we're considering the parent function to be f of x, which is equal to x squared. So we're saying, okay, some variation of the parent function is when this coefficient here is negative. Now, when you graph it, what happens is this is the parent function f of x, and right here, this is the new function g of x. And what it looks like is it looks almost identical, except it's reflected over the x-axis. Reflection means that it flips over, okay? So it's been reflected over the x-axis, and the reason why that is this is the parent function. This is the table of values of this is the input values here, and here's the output values of f of x and g of x. Now the original equation, the original parent function has values of 9, 4, 1, 0, 1, 4, 9, right? Those are classic. We've seen those before. It's just the squares of -3 to 3 inclusive. Now what this new thing does is what this new a value does is that after the input value has been squared, it's been multiplied by -1 essentially, right? This is a condensed version of this, -1 times x squared. So it just takes the original output values here and it squares them. So instead of getting 9, 4, 1, 0, 1, 4, 9, you get -9, -4, -1, and then 0's opposite is just 0. And then, so what it does is just takes the opposite of all the values. So what ends up happening is that the y values, since they're all negated, they flip over the x-axis, right? It makes sense that the input values remain the same, the x's are the same, it's just the y values are become their opposites, which flips it into quadrants 3 and 4. Okay, so when the a value is negative, not just -1, when it's negative, it's going to reflect over the x-axis. So basically, a mnemonic to remember this is when this is negative, it makes like a frowny face, right? So if you're thinking about this as like as a person or a smiley face, that when it's positive, it makes the quadratic makes a smile. When it's negative, the quadratic makes a frown. Okay. Okay. Another value for a that we're going to look at is when a is a fraction. So it's when it's between 0 and 1. All right. Now, remember when it's 1, it's just the parent function. That's just f of x is equal to 1 times x squared. That's just the original function. Now, when a is a fraction, I want you to look at the table and see what happens. Remember, this is the old output, the input values, and this is the output values for the parent function, and these are the output values for this new function g of x. Now, what happens is it takes all the old output values. So remember, it's happening outside the square. So first we square them, we get 9, 4, 1, 0, 1, 4, 9. And then we take half of all those values because it squares it and then takes half of it. So now we have 4.52, so it's half of all the original values. So what that looks like is it sort of reduces the output value, so it like shrinks the output values. So it actually, we call it a compression because it pushes down this. If we think of this like kind of as a spring, it pushes down the value. So this right here, the inside one right here is f of x, that's your original, and the outside one is your g of x. Okay, now I have this picture of a hand pushing a spring down, compressing a spring, because what ends up happening is that we think of this, imagine like a hand being here, right? I'm going to draw a horrible picture of a hand here, but a hand pushing down on the original equation, and what it would do is it would flatten the parabola a little bit more. So that means that it's the bowl of the parabola ends up being wider than it was originally. Okay, so what used to be like this is now the bowl is wider. Okay, and that happens when the number you're multiplying outside is a fraction. Okay, let's look at when a is greater than 1. When a is greater than 1, so like let's for instance talk about a is equal to 2. So again, this is f of x, and this is your new value g of x. All it does is it takes the output values for f of x and it doubles them. So instead of 9 you have 18, instead of 4 you have 8. So what happens is the parabola actually goes up a lot faster. The y, for the same value of x's, the y value increases faster. So what that looks like is this inside curve is your new g of x, whereas the outside curve now is your old f of x. So it looks like taking a spring and pulling it apart. So we're stretching a spring out. And here I have some images of a spring being stretched out. So when it's stretched out, it makes the it makes the bowl become more narrow. So here a vertical stretch narrows the bowl of the parabola, and a compression widens it. Okay? So it's going up a lot faster than it used to. So this is the inside one. Okay, now in order to figure out how to find the equation of a quadratic function that's already been graphed, we're going to have to start noticing some things here. So first of all, it is a frown, essentially, right? So it's like we know the value of a is going to be negative. And we can also notice, and you might not see this initially, but as you get used to these parabolas, you'll notice that the bowl has been widened. So first of all, we know a is going to be negative, and we also know that a is going to be a fraction, because remember, a fraction will widen the bowl. Now, in order to figure out what a is, what we can do is we can take a value that has been determined on the graph, a point that's on the line right here, which is 2, -1. Or 2, -1, and we can put that into our formula. So let's say we're looking at g of x is equal to some value a times x squared. Well, here I can put this in for g of x, so we know that the y value is -1 when the x value is 2, so a times 2 squared, and we can just solve for a. It's that simple. So we have -1 is equal to 4 times a. Notice I just squared the 2 and I brought it out as a coefficient to the a. And then let's divide each side by 4. So we have a is equal to -1/4. And that's it. So our g of x here, our function is -1/4 times x squared. So this is a combination. Notice that it's both a fraction and it's negative. So it's a combination of transformations. The image has been reflected over the x-axis, and it's also been widened. The bowl has been widened. Okay? And that's simply how you figure out the equation here. We can check our values by choosing another value here. This is the value, this is the coordinate here of 4, -4. And I can put this into the equation and make sure that it's correct. So we have -4 is equal to 1/4 times 4 squared. Well, -4 would have to be 1/4 times 16. Whoops, that should be negative. Times 16, and it is. -4 is equal to -1/4 times 16 is -4. So that checks out. We checked out two values. And certainly when x is 0, y is also 0. That's another value. All right, and that's the end of the lesson for today.